Hello my friends, in this video we're going to test three-phase motors to see if they're faulty or good. We're also going to look at the nameplates, see what that tells us and what is important for us on the nameplates. Then at the end of the video I will give you the common causes for what damages motors. Guys, please like, subscribe, comment and watch till the end. Let's get into it. Let's look at what information the nameplate gives us. Let us start off with. This is a 400 volt motor, and at 400 volts it must be connected to the star configuration. Maximum amperage on it is 3.52. It's a 1.5 kilowatt, and the RPM is 1400, which says it's a 4-power motor, and it's designed to work on 50 hertz, and it weighs 17 kilograms. That's all the information that we get off the nameplate, and this is important so that you use the right motor for the right application. Okay, here in the cover it shows us how the connections work. Okay, here we've got the star configuration, which means your W2, U2 and V2 are common, and then your supply will go to U1, V1 and W1. If it was connected in the delta mode, your contact plates will run in that direction and your supply will go still to U1, V1 and W1. That is your delta connection. That would, in this motor's case, be if you had 220 volt 3-phase, which we don't have in South Africa. Let's have a look inside the motor. There you can see it's in the star mode with the little bridge pieces connecting the one side. So here's your 3 terminals where your supply will go. Here we have 2 identical motors. Let's test them and see what we find. We're going to put the insulation tester to 1000 volts. That's more than double the insulation value we need to achieve. And let's switch on. Always touch the leads together before you test, just to make sure your leads are correct. Okay, on the first motor, we go to the earth point, coil number 1, down to earth. So you can see the needle goes all the way over, and that is just over 0.1 of a mega, which is faulty. Coil number 2, faulty. Coil number 3, good. Now let's just give the shaft a spin. The bearings doesn't make any funny noises, so we can take it that they are fine. Now let's move over to the next motor. 1 probe on the earth point, and coil number 1 got an infinity reading, which is very good. Coil number 2, infinity reading, very good. Coil number 3, infinity reading, also very good. Now the next thing we're going to see is the resistance of the coils. Okay, let's just spin this bearing. Oh, these bearings aren't good. That's obviously why this motor is on the shelf. Okay, now let's go to our ohm tester with the multimeter. Set it to ohms. There's no need to check the faulty motor. Okay. Coil number 1. Gives us 1.4 ohms. Coil number 2. 2.1 ohms. And 1.6 ohms. So it shows there's continuity in all the coils. Just a quick explanation here. Okay, you've got 3 coils inside the motor. And how they're connected with the leads coming out, you'll have A, B, C, and then C, A, B. The reason it's done like that, okay, so coil number 1 is over those 2. Coil number 2 is from that one to that one. Coil number 3 will be from that one to that one. Why it's wired like that? In the star configuration, it wouldn't matter. You'll still get full power on each coil. But if you were to go to the delta configuration, by putting power over these 2, those 2, and those 2, you'll have power to each side of each coil. That is all I've got on the testing part. Now I'll tell you the common causes why motors burn. One of the causes is overloading. To prevent that, you must always make sure that your overload setting is not higher than the maximum rated amperage of the motor. Then overheating, also a very big problem, and that usually happens when your cooling fan is damaged or if the motor is in an enclosed area and does not get sufficient air to cool itself down. The third reason, which is probably the most common of all, is single phasing, which means you get power over one coil but not over the others, and the motor then tries to do all the work with one coil instead of 3 and ends up burning out. Then the fourth one, not that common, but it does happen, where motors get submerged in water. When that happens, do not switch the motor on. Open the motor up, strip it, clean it with distilled water or electrical cleaner, and then dry it out with a lamp or a source of heat, a heater, whatever. And only once it's dry, then first insulation test the motor. If it tests fine, then you can put power to it. In most scenarios, you can save the motor doing that. My friends, thanks for watching. Please like, subscribe, comment. It will help the channel grow. Thank you. Catch you in the next one.